Okay, in lesson 4.4 we continue our discussion on transforming these quadratic functions, okay? Now, when we look at this, some vocabulary here. Anytime we compress, we shrink a figure, right? And when we talk about shrinking a figure, we basically get wider, okay? So if we compress, we get smaller or wider, okay? When we stretch, it basically means we get more narrow or skinnier. So if I take this and I stretch it like a rubber band, it's going to get more narrow, okay? Now, when we graph, right, when you stretch or compress a function, you change the shape of it. Now, all of these will be in a U shape and continue to be in a U shape, but some are going to get more wider or narrower. So we're going to talk about stretching vertically, compressing vertically. Then we're going to talk about stretching horizontally, compressing horizontally, right? And then finally, how do we flip? Okay, well, here's the thing. If I give you the parent function f of x equals x squared, and now I'm going to say g of x is some number k times x squared. This k is what compresses or stretches the function, the number you multiply x squared by. So when I go to here, it says when you stretch or compress, you are moving. When you stretch vertically, you are moving away from the x-axis. So when you look at this here is your parent function, right? Oops, it's probably not a good idea to do it like that, right? But that's your parent function f of x squared. Now, if I multiply the entire function x squared by a number whose absolute value is greater than 1, right? Such as if I pick a number greater than 1, say 3, right? What happens is this parent function gets more narrow, saying it's a vertical stretch. Now when we compress vertically, every ordered pair moves towards the x-axis. And that's when we multiply the entire function by a number whose absolute value is between 0 and 1. Meaning it's a proper fraction or decimal value between 0 and 1. And if you notice, we say compress vertically means it gets wider. So right here, when I look at the first example, right, if I'm given f of x equals x squared, that's my blue graph here. Then I'm given g of x is some number k times x squared. What is the value of k going to be so that this red graph has a vertical stretch? Okay, well, if you look here, they give us an ordered pair. Now, we know f of x is equal to x squared. We know g of x is equal some number k times f of x. Well, if f of x is equal to x squared, we're going to say g of x is equal to k times x squared. Well, if we know that ordered pair 1, 4 is on the red graph, we know x is equal to 1. We know g of x is equal to 4. So what we're going to do is plug these values in. G of x is 4 equals some number k times x is 1, so we're going to say 1 squared. Well, we know 1 squared is 1, so 4 equals k times 1. So right away, I solve and I get k is equal to 4, so it's g of x equals 4x squared. Now another way to look at that is using the 1a, 3a, 5a. If I go over 1, what happened? I went up 4. So over 1, up 4 tells me that k has to be 4. Now here, when we stretch horizontally, that means we're moving away from the y-axis now. If you look, when I get wider, right, if I graph my parent function like this, if you notice, it's carrying this point here away from the y-axis, isn't it? So when we say it stretches horizontally, it moves away from the y-axis, and if it gets wider, that means your k value is between 0 and 1. When you compress horizontally, that means you're moving towards the y-axis, meaning every point from the parent function is getting closer to the y-axis after the transformation. So you know that if it gets more narrow, the value of k is greater than 1. Alright, so g of x here for a stretch horizontally might be, say, 1/3. Here, if it's a compression horizontally, it might be 4x squared. Okay, so let's take a look here. Flipping right away, right? The y-coordinate switches sign when k is negative, right? So when k is negative, or basically you're multiplying the entire function by a negative number, meaning if I just do negative 1x squared, what that's going to do is take the function that opens like this and it reflects it over the x-axis. Now, a flip over the y-axis is when the x-coordinate switches signs. So when you multiply every x value in the function by a negative number, what's going to happen here, right? So if I put a negative here, what's going to happen is it's going to flip it over the y-axis. So it's almost like this comes like this, and when it reflects, this side comes here, this side flips and comes here. Okay? So if I had to go ahead and determine what the shifts on or the equations are here, we're going to try and make this as easy as possible. Okay? Now, number one, you know you're starting with the blue graph. What did you do from the blue to the red? Well, you know you went down one. So right away you know g of x is going to equal something x squared minus 1. What I have to figure out is what number is going to be in front of x squared. Well, if I look here, my next ordered pair, right, that's nice, is if I go over 1 to get to the graph, how many do I have to go up? I have to go up 1, 2, 3, 4. Sorry, it's over 1, up 4. That's what I have to do. And since I had to go over 1, up 4, and it got narrow, I know it's 4x squared. Now, if this is compressed vertically by a factor of 2, and compression vertically means it got wider, right? So right away, I know I shifted from 0, 0, and I went left 2. So right away, I know g of x is equal to go left 2, I know I'm taking x, and I'm going to add 2, and then square it. Now, it's a vertical shift, or vertical compression of 2. But since it got wider, right away I know if it gets wider, it's 1 over the factor. So this is going to be 1/2. Oh. So if you get wider, you know it's a fraction and it's 1 over the factor. Okay? And if you look here, you should notice you went over 1, up about 1/2 on the graph. So let's look at the checkup here. So what is g of x? G of x is the red, right, graph. So right away we know our vertex is at 0, 0. So we know right away it didn't translate. So it's just something x squared. So we have to figure out what we're multiplying by here. Now it's very difficult to tell how many we go, if we go over 1, how much we went over. So we're going to use the point that's given to us. So we're going to say x is equal to -5, g of x is equal to 1. And what we're going to do is we're going to say g of x is equal to k times x squared. So g of x gets replaced with 1 equals k times -5 squared. That's going to give me 1 equals 25k. Because what you have to understand is -5 squared is 25. So what is the value of k? When I divide by 25, I'm going to get k equals 1 over 25. So g of x in this case would be 1 over 25 x squared. Now remember, you know this has to be a proper fraction, meaning a fraction whose numerator is smaller than the denominator, right, if the graph gets wider. And if I look, this graph got wider than this, so I know that's a fraction. Next one, right, what is g of x? If g of x, again, is equal to f of x, and f of x is x squared, we know it's k times x squared. So in this case now, I'm going to replace g of x with 16. This is basically your y value, equals k times x is -1, so -1 squared. So 16 equals -1 squared is 1, k, so k is 16. So right away from here, right, if k is 16, I know g of x is equal to 16x squared. So here, it says circle the correct answer and fill in the blank. It says if f of x equals x squared and g of x equals 5x squared, then the graph of g of x is the graph of f of x vertically, right? And remember, if this number is bigger than 1, right, you know it's going to get more narrow, which means it's a vertical stretch by a factor of 5. So it's stretched by a factor of 5. Next one. Graph of g of x is the graph of f of x horizontally. Now, horizontally, did it get more narrow or wider? I look at this. Since it's a fraction, that tells me it's going to get wider. So we know it's a horizontal, right? Horizontal stretch, right? Because remember, if you stretch horizontally, that means it's getting wider. And it's by a factor of 5. Remember, when it stretches horizontally, it's always going to be your denominator. So it's a stretch with a factor of 5. The next one, if f of x is equal to x squared, g of x is equal to 7x all squared, then the graph of the function is a graph of a horizontal. Now, here's the thing. When it's a horizontal stretch, that means it gets wider. If it's a horizontal compression, right, it means it gets more narrow. Okay? Well, this ends up being the same as 49x squared. And if this number is bigger than 1, you know it's going to get narrow. That 49 makes it narrow. So you know there's a horizontal compression, right, by a factor of, in this case, it's 7. Now again, if you forget what they are, you can always go back to these charts. A stretch horizontally makes it wider. A compression horizontally makes it narrow. Here, a stretch vertically makes it narrow. A compression vertically makes it wider. Okay, so you can always go back and review that. Now here, the function g of x is the graph of f of x equals x squared and has been vertically stretched, right, by a factor of 2. Vertical stretch means it's going to get narrow, right, and reflected or flipped over the x-axis, meaning it's going to be like this. Anytime you see this, you know that value of k is negative. Since it gets more narrow, I know I'm going to use 2. So in this case, g of x would be negative 2x squared. Okay? So, right away here, it says, suppose f of x equals x squared. Sketch a graph of negative f of 1/5 x to show the real shape and direction. Since this is negative, we know it's going to flip, right? So since you know this is negative, you know it's going to open down and it's going to get wider, right? So when I look here, right, this will get wider like this. Okay? So the next function, g of x equals 4 times f of x. Now, if we do 4 times f of x, we know g of x is equal to 4 times x squared, right? So this one, you know the 4 tells you it's going to get more narrow, right? Well, I know the vertex of this is going to be at 0, 0 because it didn't go up, it didn't go down. But if you remember the 1a, 3a, 5a from back in the day, right? I'm going to go over 1, right, up 4, because 4 times 1 is 4. So from here, over 1, you got to remember that these tick marks are in 2. So over 1, up 4. Now I'm going to go over 1, right, up 3a would be 12. So over 1, up 2, 4, 6, 8, 10, 12. Is that right? So now, if I look, I can match it up on either side, and that would be your graph there. So in this example here, it says the graph of g of x shown below resembles the blue. So g of x is this blue graph, right? Now, if that's the blue graph, what is happening? Well, you know the vertex went up 2 units. It went up 2 units. So right away when it goes up, you know you have x squared plus 2. But because it flipped, you know the number in front of x squared has to be negative. And did it get wider or narrower? No, it stayed about the same. So right away it flipped, so you know it's negative x squared. Since the vertex went up 2 units, we're going to add it, so you would get choice A. Okay, now, the last one here, for some reason, this answer choice didn't come up. Right, let me write that in. It should be g of x equals negative 1/2 x all squared minus 3. Now with this one, it says the graph of g of x shown below resembles the blue graph of f of x equals x squared. So right away you know this one opened down, right? If it opened down, you know you have a negative, right, in front of that x squared term. Now you know the vertex shifted down, that's 2, and it's halfway in between, so it went down 3, so you know you're subtracting 3. Now if you notice here, this got wider. And because this got wider, right, you need to know the number in front is going to be a fraction. So which one has that? It would be letter B. Okay? So, Do me a favor, try your best on this, and let me know if you have any questions.